All right, so hope everybody's doing all right. Another weird week in the books here with STAAR testing going on for Algebra 1 and biology. So for this one here, we have to rewrite these two in their opposite forms. So the first one's given to us in radians. We need to turn it into degrees. So that means we're going to multiply it by 180, because whatever we want it to be in, it needs to be on the numerator, over pi. So that's going to cancel the pi. We can simplify this down a little bit so it makes the multiplication just a little bit easier. 180, of course, is divisible by 8, they're both divisible by 4. So 180 divided by 4 is 45, and 8 divided by 4 is 2. Now we can go ahead and multiply across. 3 times 45 is 135, and then 2 on the denominator times 1 is just 2. So 135 divided by 2 gives us 67.5 degrees. Number 2, we're going the other way, so we need to flip that conversion fraction. So it's 135 times pi over 180. Now we can go ahead and multiply across. 135 pi over 180, but 135 and 180 are both divisible by 45. So 45 goes into 135 3 times and 180 4 times. So that means we got 3 pi over 4. All right, so today we're going to be taking a look at our trig functions and just of general angles entirely. We'll also be looking at a couple other things like the law of sines and the law of cosines. And a lot to get through today, so let's get going. These are all the things we're going to see: quadrantal angle, reference angle, law of sines, solving a triangle, ambiguous case, and law of cosines. So solving a triangle just means you're going to use all these different things, and including everything for right triangles too, to find if a triangle, or find what the sides and what the angles are of a triangle. Sometimes there might not be a triangle that's possible with what's given to us. And that's where the ambiguous case comes in, and that has to do with the law of sines, and we'll see that here in a little bit. Up first, though, we're just going to look at trig functions of general angles. So whenever you're given this, you can just use Pythagorean Theorem. So r is going to be the length of the line. It's just going to be equal to the square root of the x value out squared plus the y value down or up squared. So all you need to do is just remember these. So sine is going to be the y value over r. Cosine is the x value over r. So sine is always associated with y. Cosine is always with x. Tangent is both of them. It's y over x. And then your other ones, cosecant, secant, and cotangent, are just going to be the opposite. So the flipped or the reciprocal of the one above it. So sine was y over r. Cosecant is r over y. Cosine was x over r. Secant is r over x. And tangent was y over x. Cotangent is going to be x over y. So here we have our point that's on the line. We need to figure out what r is. So that way we can then come up with the different values for the 6 trig functions. So r is just going to be the square root of 8 squared plus negative 15 squared. 8 squared is 64. Negative or positive 15 squared is 225. When you add those up, you get 289, and the square root of 289 is 17. So r is 17 for us, x is 8, y is negative 15. Now we have everything we need to plug in and simplify, if we can, to our 6 trig functions. So sine of theta, we don't know our theta, and that's okay, is going to be equal to, remember sine is y, so it's y over r. Negative 15 over 17. That can't simplify, so that's as good as it's going to get. Cosine of theta is going to be our x value over r. So 8 over 17. And again, that doesn't simplify. And then we've got tangent of theta is going to be our y value, negative 15, over our x value of 8. Then we have the other three. Cosecant is just going to be the fraction above it, flipped upside down. So negative 17/15. Again, these aren't going to simplify. If the other three didn't simplify, these three aren't going to either. Secant is going to be 17 over 8. And cotangent is 8, negative 8/15. And there we go. There are the 6 trig functions for this theta that we don't know that has the r value of 17. The line goes out through the point 8, negative 15. Now, could we find the angle? Yeah. We can use our trig functions and inverse trig functions to find those. We're not worried about that right now. So these are the quadrantal angles. These are basically the angles that are on the axes. So if it's out to r0, still our r is whatever distance it is out, then your theta is 0 or 0 radians. If it's going straight up, it's 90 degrees, and that's pi over 2 radians. Out to the left, 180 degrees is pi radians, and 270 down, the negative y is 3 pi over 2 radians. So now we have this one that's a terminal side of theta in standard position, contains the point at 0, negative 2. So we know our x is 0, our y is negative 2. Let's figure out what r is. Well, 0 squared is going to be 0, right? So is there really a point to doing this? Not really. 0 plus 4 is going to be 4. And the square root of 4 is 2. So r is 2. So now in the same process we done the last one, we got find those 6 trig functions again. So sine of theta, which we know it's going down, so theta is really 270, but that's okay. So sine of 270, or 3 pi over 2, is going to be our y value, negative 2, over r2, which simplifies to be negative 1. Cosine of theta is going to be 0 over 2, which is 0. And tangent of theta is going to be negative 2 over 0. That's a problem. That's undefined. Can't divide by 0. Cosecant theta is going to be a negative 2 over 2. So 2 over negative 2, really. But again, that's negative 1. Secant of theta is 2 over 0. Again, we got that problem where we were dividing by 0, so that's undefined. And cotangent going to be of theta is equal to 0 over negative 2, which is just 0. So there's our 6 trig functions for this specific quadrantal angle. Now, just FYI, every quadrantal angle is some combination of these 3 things: negative 1 or positive 1, 0, or undefined. They're all going to be either plus or minus 1, 0, or undefined. It just depends on which one you're talking about. So reference angles. So anytime you're given an angle, the reference angle depends on where you are. So if you're in quadrant 1, your reference angle is the angle you're looking at. If you're in quadrant 2, your reference angle is going to be 180, or pi, minus that angle that you are given. For quadrant 3, it's going to be the angle you're given minus 180, or pi. And then if you're in quadrant 4, 360 minus that reference angle, or 360 minus the angle you're given to get the reference angle, or 2 pi instead of 360. So we want to find the reference angle here. We need to figure out first, where is 5 pi over 6? So we're going to sketch the angle and then find this reference angle. So 5 pi over 6, it's not quite 6 pi over 6, right? 6 pi over 6 would simplify it to be, it's negative as well, but it would simplify it to be 6, so 6 pi over 6 would simplify to be just pi, which is 180, right? So it's not quite to that 180, which means it's pi over 6 shy of that, right? And it's negative, so let's go in this direction, negative 5 pi over 6. So there's our angle sketched. Now we need to find the reference angle. Since it is in quadrant 3, we're going to subtract 180 from this, or in this case, pi. So negative 5 pi over 6 minus pi. All right, so actually I take that back. Because we are going the other direction, we have to do things a little bit differently. If we were going in the positive direction, yeah, we could subtract pi away. But because we're going in the negative direction, we can't do that. So what we are going to do instead is do as if we were going the positive direction, but we're up in quadrant 2. So it would be 180. Gosh, not 180, pi, because we are in radians here. And again, since we're going the negative direction, instead of instead of subtracting the 5 pi over 6 to it, we're going to add it, since it's negative. It's really kind of like you're doing the absolute value of it in this case, I guess. Or you're adding it, either one. But that's going to leave us with pi over 6. That is our reference angle, because that's what remains here, right? Remember, we even said that we had 1 pi over 6 shy of getting to that negative pi, or pi in this case, either way, as our reference angle, or as our angle, either way. There we go. So the next one's a little bit easier because it's in degrees for one, and it's going in the positive direction. So try this next one out.